Welcome back. I'm Dr. Mohammed Aoudi, and today we continue with part 2 of our deep dive into arrays in C#. In part 1, we covered array basics, declaring arrays, accessing elements, and simple looping. In this second part, we'll move into more advanced techniques, summing array elements, visualizing data with arrays, using Foreach loops, and exploring powerful built-in array methods. Let's continue building your C# mastery, starting now. Now let's look at an essential operation, summing the elements of an array. In this example, we initialize a 10-element integer array with test scores. We then loop through each element using a for loop, adding each value to a running total. At the end, the total sum is printed to the console. This simple yet powerful technique is foundational for tasks like calculating averages, totals, or other statistical measures in real applications. Arrays aren't just for numbers. You can even use them to generate simple visual outputs. In this example, we use an array to create a bar chart representing grade distributions. Each element of the array corresponds to a range of grades, and the value determines how many stars are printed. Notice the special case for the 100 mark. It is labeled separately. This shows how arrays can drive dynamic console-based graphics, bringing data visualization to life even in simple programs. One major advantage of C# compared to older languages like C or C++ is automatic bounds checking. Whenever you access an array, C# checks at runtime to ensure the index is valid. If you mistakenly go out of bounds, C# throws an index out of range exception, protecting memory safety. This built-in protection helps prevent common bugs like buffer overflows. When you simply need to visit every element in an array without modifying them, Foreach is the way to go. Foreach automatically loops over every element in sequence without needing to manually manage an index. It's cleaner, safer, and makes your code more readable, especially for beginners. Here's a practical example of using Foreach to sum array elements. Notice how much simpler and cleaner the code becomes. You don't even need a counter variable. The loop retrieves each value directly, one after another, and adds them to the total. The syntax for Foreach is minimal. You specify the element type, a variable name, and the array or collection you want to iterate over. Foreach is great for when you need to read data, not modify it. However, you cannot skip elements or change elements using Foreach. It's read only by design. The Foreach loop isn't limited to integers. You can use it with arrays of characters, like vowels, arrays of strings like names, or even generic collections like listint. The syntax stays consistent, which helps maintain simplicity across different types. You can make Foreach loops even more concise by using var for implicit typing. For example, instead of writing Foreach, int num in numbers, you can simply write Foreach, var num in numbers. The compiler infers the correct type for you, reducing redundancy and making the code cleaner. When should you use Foreach and when should you use for? If you need simple, safe, read-only access, use Foreach. It's easier and less error-prone. If you need to modify elements, access specific indices, or skip elements, use for. Both have their place, and a good programmer knows when to use each wisely. Here's a quick guide. Use Foreach when you want to iterate through every element without changing them, focusing on readability. Use for when you need more control, to modify elements, skip over elements, or perform conditional processing during iteration. Another great feature of C# is support for implicitly typed variables inside Foreach loops. You can write Foreach, var number in myArray, instead of specifying the exact type. This improves readability, especially when dealing with complex object types or link queries. You can even use implicit typing when declaring arrays themselves. With var, the compiler automatically figures out the correct array type based on the initializer. For example, var numbers equal new array 1, 2, 3, 4, 5 is an int array. Var mixed values equal new array 1, 2.5, 3 is a double array. Var words equal new array apple, banana, cherry, becomes a string array. Let's start with two fundamental methods, binary search and clear. Binary search is used to efficiently search for a value in a sorted array. It returns the index if the value is found, or a negative number if not found. In the example shown, we search for 6.8 in a sorted array of water depths. Clear, on the other hand, resets a portion of the array to its default values, 0 for numbers, false for booleans, and null for references. Both of these methods are extremely useful when managing data arrays dynamically. Now, let's explore clone and copy. Clone creates a shallow copy of an array, returning an object which you then cast back to the original type. This is useful if you want a duplicate but still share references for non-primitive types. Copy is a bit more precise. It allows you to copy specific elements from one array to another, controlling the starting points and length of the copied section. It's a vital tool when working with subarrays or merging arrays. Next up, copy2, get value, and set value. Copy2 is another way of copying elements from one array to another, specifying the target starting index. Get value retrieves an element's value by index dynamically, and set value allows you to modify the value at a specific index dynamically. These methods are particularly useful when dealing with generic programming or writing dynamic array handling code. Two very practical methods here, sort and reverse. Sort automatically arranges your array elements in ascending order. No need to write your own sorting logic. Reverse flips the order of the elements in place. These operations are extremely common when you need to prepare data for display, analysis, or comparison. Here we focus on searching inside arrays. IndexOf finds the index of the first occurrence of a given value. If the value doesn't exist, it returns -1. Last IndexOf works similarly, but finds the last occurrence instead. These methods are essential for searching and handling duplicates inside arrays. Now some slightly more advanced operations. Resize resizes an existing array, expanding or shrinking it. If you grow an array, the new slots are initialized to default values. Exists checks if any element matches a condition you specify using a predicate. Find locates the first element matching a condition. These methods are crucial when working with dynamic, changing datasets. Let's dive deeper into searching with conditions. FindAll retrieves all elements that match a certain condition and returns them in a new array. Super useful for filtering data. FindIndex finds the first index of an element matching a condition. FindLast finds the last matching element based on a condition. Together they give you total flexibility when searching inside arrays based on custom logic. And finally we have FindLastIndex, which gives the index of the last element matching a condition. Foreach, which lets you perform an action on each element in the array, like printing or modifying, without manually looping. And TrueForAll, which checks if all elements satisfy a condition, returning true if every single one does. These tools complete our toolbox for handling arrays efficiently in real-world C# programs.